Good morning, everybody. Thank you so much, Critical Insight, for inviting me to be a part of this. Thank you, Tor, for your presentation. I'm still Matt Bagwell. I'm wearing several hats, including, obviously, Wi-Fi connection and internet. It's great to present. I'm here representing a company called Deep Green. We are a data center operator. So what that means is we design, build, and operate data centers. But I hope that I go to prove that we're a different kind of data center. So let's see how we get on in the next 20 minutes. I think that you're probably very familiar with certainly what data centers are conceptually. Some of you will have been inside data centers, but for those of you who haven't, this is what you might find. Tor similarly showed you some pictures there of racks. You're going to see racks and racks of technology, principally computing technology, switches with also cooling technology adjacent to it. So you're going to find these large spaces full of computers all screaming at each other, very often in centralized environments in industrial precincts of our countries. So you might expect as a data center operator that our mission statement might be something like to harness the opportunity in, for example, artificial intelligence. And I'm sure that subject has come up on numerous of these presentations, to harness the opportunity of, say, cloud. But actually, it's not. Our mission is to draw as much demand as we can as possible, as fast as possible, away from existing harmful data centers, and then convert that demand into what we call edge data furnaces. And I'll explain what I mean by that as we go through. Why are we doing this? Well, the purpose of our company is to reduce climate anxiety. And the way that we'll do that is demonstrating that there is a solution to some of the challenges that we face in infrastructure, data center infrastructure, with a distributed, scalable, and circular reality, and that can be to the benefit of all stakeholders. So what do we care about as a data center business? We care about the impact of what we're building and operating. So we spend a lot of time considering what it is that we're trying to do and the impact of what that will be, whether that's from, say, a carbon impact, but as importantly, a societal impact of what we'll build and operate. We obviously have to think about the efficiency as the density of racks and chips increases. We have to think about the resources that we need to power those and to cool them. And we also think about and care about very much this opportunity within systems thinking. And I'll explain what I mean about that. We don't consider ourselves as an isolated business, but see ourselves within a larger ecology of businesses. And so we use systems thinking to think about what we deploy. However, what do our clients care about? And when I talk about clients, I'm talking about the people who co-locate their computing in our facilities or rent our bare metal. Well, they care about what all clients seemingly care about. They want things to be very cost effective and arguably cheaper. They would like things to be very flexible and arguably faster in terms of certainly build capacity. And they want things to be better. And more recently, better has meant that they want that stuff, the technology and their infrastructure, to be sustainable. Now, just a point about the title of the presentation. We don't waste energy. If we look at natural systems, there's no notion of waste within natural ecologies. Waste is a human verb rather than a natural noun. So we don't waste energy. In fact, what we do, the innovation at the heart of this presentation, is that we recapture it. And Tor mentioned the fact that there is obviously an opportunity in recapturing heat. That's exactly what we do. We recapture the heat that our computing generates and then distributes it for free to where it can be used. So clearly that requires us to think about where we're placing data centers and who will offtake that energy and be able to use it. The unlock economically is the fact that we don't charge for that energy. Some of you will know us. We are the people who famously built a data center within the plant room of a swimming pool in 2022. So we took a 50 kilowatt instance, comparatively small by any measure, and placed it in the plant room of a swimming pool in Exmouth. Exmouth is in Devon on the southwest of the United Kingdom. And planted it right next door to the filtration systems and the conventional fossil fuel furnaces, with a heat exchanger so that the cold water from the pool comes into the heat exchanger. We have fully immersed GPUs running, and that provides heat into the heat exchanger. The water returns back into the pool and into that body of water as warm water. It's also possible to heat the atmospheric temperature and the shower units, for example. So if heat reuse is the solution, what was the problem that we were trying to solve? So we need to take a step back to consider the context. And once again, Tor was a brilliant preface here, talking about some of the challenges that we face with the exponential growth in compute demand. Here's the outside of a data center. This one, I think, is a 200 megawatt instance for Meta. These huge Leviathan buildings and industrial estates with as many coolers and chillers as there might be GPUs. Absolutely massive facilities. And as you all know, the cloud is within them. I love this idea that when people sort of say, oh, my workloads are in the cloud, they think it's some kind of abstract place that doesn't exist, a little bit ephemeral. But actually, the cloud is on your desktop, or it's on a machine under your desk, or it's in a rack in your building, or it might be in a massive data center. And so the cloud does exist, and it does have an impact. In those data centers, obviously, masses and masses, tens of thousands of GPUs and CPUs whirring away. As a consequence of this, of cloud computing and its associated industries, for example, networking, there's a contribution, a negative contribution, an impact to global greenhouse gas emissions between 2.5% to say up to 4%. And when you're talking to somebody about the impact of things in human society, for example, commercial flights, that might be in their top 3. Very few, if anybody, will ever talk about data centers at the moment, but I think the time is coming where people are far more aware of it. And we know that we're in the middle of a climate emergency. We can see this with changes in our climate, in terms of our agricultural yields and our weather. Hold on a moment, I'm going to shut the door, sorry. Particularly traveled into a place that would be the perfect environment for a presentation, and it appears not. Nevertheless, we are in the middle of an emergency, and so it requires us to be urgent about the thinking, the systems thinking about our use of energy and resources. And right at the heart of that here in the UK is the question about power. First of all, what is the type of power using, how it's generated, and also where is it? For any of you who operate in the UK, you know that there is a tension between what we want to be able to build in terms of infrastructure and power availability. This data center at 200 megawatts could have powered almost 500,000 homes in the UK, but it doesn't. Because it doesn't recapture the heat, it is actually an opportunity cost when a local council is considering approving a planning application for a data center. They do so at the expense of other things that they could build and implement with that power. As a consequence of that, we find ourselves in what I would call a cultural war, where there are already moratoriums about the building of data centers and their use of resources. Just as part of a kind of context here, we know that we want to capitalize on the opportunity that high performance compute, AI, and these other sort of like incredible forces are able to generate. We know that we want to be at the heart of that. And it's one of the many reasons why data centers have now been designated as critical infrastructure. However, we also know that sort of the numbers that we are publishing about our use of power may actually be underestimating our impact. Data center power use surged 6-fold in 10 years, potentially, and I'll come on to think about what that might mean. Potentially that our impact is 662 times higher than big tech company claims. So this is the backdrop. We have this tension between the AI boom and also the environmental impact of what is loosely known as the internet or cloud. 3 stakeholders here, protest and protesters, who are sort of fueling those moratoriums on data center design, build, and operations. Politics, central and decentralized governments, wanting to sort of capitalize on the opportunity, but knowing there might be a cultural backlash. And then in popular culture, we're beginning to see a lot more content about the impact of data centers. Very obviously about, say, for example, the consumption of water on an AI inference. And the thirst for compute power is not going away. So this morning, I put a little query into ChatGPT and said, hey, why don't you say hello to the folks here in the presentation at Critical Insights, and what are you excited about? And ChatGPT was particularly excited about the sessions on data center sustainability and innovations like waste heat reuse. This particular single inference, this single query to ChatGPT may have drunk the equivalent of a 500 milliliter bottle of water. I did a bit of calculations here. If the growth in data center power usage was only to increase threefold by 2050 in the UK, that would be 83% of the power that we generate being deployed into data center powering and compute powering. So you can see the numbers are absolutely exponential. So is there an alternative, a more positive future to this content that I've described? Well, the wonderful thing is that when we do computing is like a furnace. You'll remember, whirring of fans in the machine under your desk or in your laptop. 96% of the electrical energy that goes into a compute system is able to be recaptured. And if you recapture it, you can reuse it. This energy becomes even more powerful when it's redistributed into communities and provided for free. We like to think of this as like a two-cell organism. So you've seen the most simple version of this, a deep green data center built within the fabric of a leisure center, for example. Cold water comes from the swimming pool through heat exchange and returns as warm water and heat into that environment. So a simple symbiotic relationship between a data center doing compute and a swimming pool as the off-taker of that energy. And it's our ambition as Deep Green to distribute 300 megawatts, so that's 1.5 times the size of that Leviathan building I showed you, of computing across hundreds of data centers. So rather than a centralized way, do it in a distributed edge way so that we can have a positive impact on the communities within which we build. We're not just heating swimming pools. So if I take this simple model, I can begin to extrapolate out what we call industrial ecology parks. So thinking about multiple businesses all benefiting, mutually benefiting, or communities benefiting from free heat. In this example, here a data center is supplying heat into an energy center. Within that energy center, there's a district heat network. Again, talked about these. That heat network, yes, could heat swimming pools, but also in the wider community, hundreds of thousands of homes potentially, and many light and heavier industrial uses. 30% of industry production is reliant upon heat at some source. So we begin to solve, when we think like this in a systems way, we begin to solve existential problems. How are we going to heat our industries? How are we going to heat our public spaces, our private spaces? How will we electrify the heat in our homes? And indeed, something like wicked problems, we call them wicked problems, like the future of food production. With an increased population and potentially the challenge about food production, we need to think about the food of the future. And here's an example of that, just to come back to this ecology. A deep green data center adjacent to a controlled environment agricultural lab, and to put that in simple terms, say, for example, that's a greenhouse. The heat goes from the data center into the greenhouse, but also could go into an energy center, into a direct air capture machine. Direct air capture machines extract the CO2 from air, and we could use that CO2 in the laboratory environment in that greenhouse. So you've now got a sort of a multi-directional use of heat in order to do food production. These ecologies, and there's more that I could show you, that these ecologies generate what we call planetary and social license to operate. So imagine if the planet and communities were shareholders and stakeholders sitting on your board, for example. Would they give you the license to operate as data center infrastructure companies? We believe that when we are more generous and contributing value, it does increase the social license to operate, whether that is in decarbonisation or whether it's in social benefits. This all fits within new frameworks of economic thinking. So without going into the detail of all 8 of the parameters of a regenerative economic framework, there's a couple I'll call here. When we build data centers into the fabric of our communities, they need to be in the right relationship with the buildings and the peoples around the places where we're building. We should honor the place and the community and actually involve them in the process, understanding what is our long-term economic benefit of being a part of their community, for example, in terms of jobs. Just to put a little bit of detail here, a single instance, 1 megawatt, that's 20 times the size of Exmouth. So a 1 megawatt instance heating, for example, a large Olympic swimming pool or another use, has these quantifiable benefits. 730 tons of CO2 equivalent, that's avoided emissions. 4 gigawatt hours of electricity over the course of the year. But perhaps most obviously and most practically, over £250,000 worth of saved energy costs. Now that might mean the difference between a pool being able to operate or not operate or increase its operational hours. They may redistribute that wealth in a way, for example, affording people who can't afford swimming the opportunity to use their facilities. It makes a huge material difference to the economies within which we are a part. And that's some of the measures that we use, but there are more detailed measures. I won't go into the detail of this, but of course we have to think about PUE or net PUE. But increasingly, because it's the right thing to do and we will be regulated to do so, we need to think about energy reuse factors. How much of the energy going through the data center are we recapturing and repurposing? Now, when we go and meet a host, we will operate where there is grid power or behind the meter, so solar, battery, and other heat generative sources, where there is space, and we like to build in the fabric of a property or adjacent to it in modular and containerized solutions. There needs to be connectivity, and often ultra-fast connectivity with fiber. And we need to think about the use of that energy. How do we contribute energy in a meaningful way to the local community? And what does that do for their long-term economic benefit? In 2025, and I'm coming to the end now, so I can take questions, but in 2025, we'll be planting ecologies all over the UK, whether they are relatively small instances, 200 kilowatts and above, which we will call edge in, or whether they are cloud out, much larger instances between, say, 5 and 10 megawatts, distributed all across the UK and potentially beyond. What we're intending to do is build an exemplar for the industry. We are different from the majority of data center operators. We want to create a beacon for this regenerative economic framework. How can we coexist in a way that is mutually beneficial and respectful of the planet and respectful of the communities within which we exist? How do we share the economic and societal benefit of free energy? So it doesn't need to be a cost to anyone. How can we share that with everyone? Whether that's into district heating systems, swimming pools, agriculture, or many, many other uses. It is time for us to rethink the way that we build and operate data centers. And I hope that by showing you what we're doing at Deep Green, you're inspired to see that there is a brighter and warmer future ahead. Kaylee, thank you very much for affording me the opportunity to present this morning. I think I've come in a little under time, but we can...
No, that was... I was going to say that was the perfect recovery. Thank you so much. There's no problem. We always expect a little bit, of audio-visual complications when we do these things. That was fantastic. Thank you so much. You've covered some really interesting issues. I'm just going to jump us quickly over to questions, if I may, so we can get them in before the next session. Swimming pools in the UK keep closing. Do you think this could be a good way to keep them open by co-locating them with a data centre?
It's a brilliant question. Thank you for the question. And the answer is simply yes. When we did the swimming pool in 2022, it was intentional. We care very much about the fact that public services are under constraint. They don't have the resources that they might wish to have. If we can reduce or even remove the cost of energy, in the greater part anyway, then it will either maintain what they're doing, extend what they're doing, or potentially even save pools. There are hundreds of pools in the UK that have closed. And working with Swim England, it is our intention to ensure
Yeah.
that is less true in the future. Public health is critically important, and swimming pools are very much a part of that. So absolutely, great question, and yes.
Fantastic, thank you. Tor previously mentioned he doesn't believe district heating to be a good solution for the UK, especially when compared with the Nordics. How do you feel about that? Do you agree?
I think that district heating systems are inevitably part of our energy future in the UK.
Yeah.
They are complicated systems to build. The office next door is a district heating system provider. Tor answered well, I think. The contribution of data center heat is only one of the heat sources. When a district heating network provider, an operator, looks at an area, they'll look at all of the ways that they can capture heat. So that might be thermal heat in water, for example. Yes, it could mean putting a data center into an energy system. So it's part of an ecology. Data centers in and of themselves are not the only answer.
Yeah.
Yes, at the moment in the UK, I think it's about 3% of heat is used is provided through district heating systems. In the Nordics, it may be at 25%. We obviously do have a delta to bridge. They will become increasingly implemented in the UK, but it's not without complexity.
Thank you. And just one more, if I can, before we move on. What future innovations are being explored to enhance waste heat recovery in data centres? Do you think there'll be new technologies that will take over that aren't being discussed at length today? It's a difficult question, but it's a good one to end on.
It's a wonderful question. I mean, you see the trajectory that Tor talked about, this projection that the computers will get denser and denser and denser and use more and more and more power. I wonder whether, and in conversations with leading scientists and researchers in AI, whether we will actually think about the way that we use code, as much as having, training for large language models, which are incredibly consumptive. What about small language models and agents, and using compostable code, such that we are not as reliant on always on very, very highly consumptive compute? And I know that's somewhat ironic given I'm an operator, but I think some of the innovations that we may not have talked about are as much in the code base as they are in the sort of the GPUs and CPU. Immersion is the other part, but we are all quite familiar with the opportunities in fully immersed technology.
Brilliant. Thank you so much. That takes us time. Thank you so much for joining us today, Matt. I really appreciate it. And for all of the moving into a different location to do an interview.
We got there in the end. So
yeah, we did. Thank you so much.
For being so patient, and it's a pleasure to be here.
Thank you. Have a great day. Thanks, Matt.
All right. Bye-bye.